Hello guys, in this video I will talk about the spiral matrix generation and what this is about. This is mostly to show you how to think about these kind of problems. Also, I want this algorithm to be readable so anyone can understand it easily. And the last thing, and this is very important, I did not add any concern about performance issues here. So if performance concerns you, I don't know, because I didn't test this algorithm, so I don't know, and I don't have any guarantee that this is the best one. Okay, so let's start. What we want, for example, this case, we want a 5x4 spiral matrix. We start in the bottom left and we go like this, till we reach the number 1. This is our goal. And how to solve this? This is very at the first look, this is very complicated, right? So let's simplify this. Let's see this as layered, and this is one layer and this is another layer. You can watch this like many sub matrix. This is a sub matrix of this matrix, this major, and we want to move here in a cycle and here in another cycle. Okay, so something is repeating. So let's go to the code, and we know that something is repeating, and we can use a while loop with the number 1 because this is C, and for now we just know this. Okay, we have a while loop. Next, what we will do in each cycle? Well, we will update the X position, and then the Y position, and then the X again, and the Y position again. Okay, so we have now two new concepts, the one for the coordinates, and the second one moving these the number of positions that X and Y can move. So let's do that in the code. So int X is equals to 0, the X coordinate, and int Y is equals to rows, the number of rows, minus 1. This is the X and Y coordinates, and also I want the X steps is equals to columns minus 1, because X will move in the horizontal here and here, so it will be the number of columns minus 1, and the Y steps will be the number of rows minus 1. Is the same thing. Okay, so we have inner cycles. So we go here, and those inner cycles can be, for example, 4 int step is equals to 0, and while step is less than X step, the step will increase the value. So this is the template, let's say, for the inner cycle. But we have four of these. This is the first one, and this is the second. So in the first we will increase the x, and the second we will decrease the y. The third we will decrease the x, and the fourth we will increase the y. Okay, so going here, matrix is equals to x and y and x plus and it is equals to number minus minus. And I forget to declare here the variable number. We want to start at the number 20, that is the number of columns plus multiplied by the number of rows. Okay, so we say that columns multiplied by rows is equals to our number. So every cycle this number will decrease, so it can have this effect 20, 19, 18, and then we will switch to the other for loop. So let's copy this, and instead of x steps we will have I'm missing here s. We will have y steps. Okay, and instead of increasing the x we will decrease the y on the y. Okay, now that we have these two, we have to add these two, another for the x. So in here the x will decrease and the y will increase in the fourth loop. So I can copy this and paste here. Let me paste correctly. So here we will decrease the x, and here we will increase the y. Okay, so the first cycle of the while has stopped, right? What we will do in the next cycle, we want to, instead of going in this layer, we want to be in this layer, so we must update the position to do it again. The last position was set, the last set position was this one, where the 7 is, but we increased the y, so now the y and x are pointing to this position again. We must say that the y will be -1 and the x will be +1 to move to this position. So we will update our x and y. So x will be plus plus and y will be minus minus. Also we don't have the same size, right? We are working on a smaller matrix here, and if you notice in this smaller matrix we lose 2 columns and 2 rows, so we will update to the x steps, that will be x steps -2, and the y steps will be y steps -2. Okay, so now we are ready to go to another cycle, but don't forget that we have this one, this will run forever, right? So we want to set conditions for this to run. So this will run while x steps is bigger than 0 and or y steps is bigger than 0. Okay, so we are ready to do our test. we copy this and we go here and paste and run, and is working. Okay, is doing this like we thought. Yes, like we thought, is moving like this. Well, sorry, is doing this thing. Okay, it works, and we have a happy cartoon here, right? Let's try another scenario. Instead of 5, we will try 4 4, and it works, and 4 3, it works. Okay, and 3 4 works, and our cartoon is very happy, right? If we try this another 2 and 5, and something went wrong, very wrong here. We have 10 9 8 7 6 5 and something 0 and 1. This is a problem, and we have a sad cartoon now. What is happening here? We start with steps x steps equals to 4, y steps equals to 1, and we start doing our first while with our first for loop, and then the second for loop, and then the third for loop, and the fourth, and the first while loop stops, and we update the x steps and y steps, right? So the cycle ends, the x steps are updated and y steps are updated. We have 2 and -1, and we have a new cycle. Why? Because we said that OR. Okay, and then we update the position to here, and since the x step is 2, the horizontal inner cycles will execute. This cycle and this cycle will execute. This one and this one will not, because y steps is less than 0. Okay, and step will start at 0. This guy will run in these 3 positions, right? And these 3 positions are compromised. Like I said before, we have OR. Let's try with the AND. Well, we have OR. Let's try with AND. Let's copy and let's paste. Let me update, because I didn't update here, 2 and 5. And let's run, and works. Okay, let's try with 3 5. And this one doesn't work. We have 15 14 13 12 11 10 9 10 8 7 6 5 4, and it stops. Okay, why? It works. This doesn't work because we have x steps equals to 2 and y steps equals to -1, and we have a AND condition, so y steps are less than 0, so the while loop will stop. We can have 2 approaches here to solve this while condition. We can overcomplicate this using many combinations of these 2 fields, x steps and y steps, until we reach something that will be very uh, effective. Okay, so something like x steps bigger than 0 and y steps equals to -1, or x steps is bigger than 0 and y steps is bigger than 0, and so forth. Or we can take we can take advantage of knowing how many positions we already reached. Okay, since we are moving the x and the y coordinates to the center of the matrix, x and y never go out of this matrix. So let's take advantage of knowing this. Okay, and to do that we will declare another two concepts. Visited, int visited is equals to 0 because on the first time is 0, and the total elements is the number of columns multiplied by the number of rows. And here in the while loop we say that our visited, this will run while we visit, our visited is less than total, right? Because we want to visit. Also, every time we affect this, we must update the visit. So every cycle will have this. Okay, and since we are testing this, I will include here. So when this reaches the end, it will stop. Okay, stop here, and stop here. Okay, so now we have a new, let's say almost new algorithm here. Let's test this. Copy and go here. We want to test the 3 and 5. Let me, because I didn't update in the source code 3 and 5, and now it works. Okay, it is working, and I think we have 𝗳𝚹 face in the next. Yeah, it's working, and 𝗳𝚹 face works. It works. Okay. There is another scenario, simple scenario, 3 by 3. It runs forever. Okay, let's stop this. So 3 by 3, and it's running like forever. Okay, let's see if I have some clue here. Well, we have angry cartoon because it's not working, and we start here 9 8 7 6 5 4 3 2, and x steps is equals to 0 and y steps is equals to 0. And okay, we are not based on x steps and y steps here, but we are based on x steps and y steps here, right? So these 4 for loops will never run again, and it means that this visited variable will never be updated again. Okay, so we are in the situation where we have a visit, the visit is equals to, this is 9 is equals to 8. Okay, so we must see this is a special case. This is a special scenario where visited is equals to total minus 1. Okay, so what we have to do here is adding some special, it can be here some special if condition. If visited is equals to total minus 1, what we must do is we want to update where we were here. We must go up and to the right, so minus y matrix y minus 1 and x plus 1, and this position will be equals to number minus minus, but this is not very, it can be just number, okay, because we will not do it again. So break, so this will break the while and the while will end. Okay, and another important thing, this is a special case because this is odd this is a odd square matrix. Okay, odd numbers here. So let's test this. Copy and go here. I must let's see, it's working with the other scenario with 5 and 4. Let's see, 3 and 4, it's working. 3 and 14, it works. It was strange because this auto adjusts. Okay, and 3 the most important one, it works. Okay, I don't know if I was missing here something, some special scenario here. I think I covered Yahoo, I covered every scenario here, but the important thing here is that you understand how to think in these situations. Okay, so this is the end. Thanks for watching and hope you like it.